Hello Year 6, welcome to your maths video for Monday. I was really impressed with your countdown challenges on Friday. Well done. It was great to see that some of you followed my link, went on and did some of your own challenges, so well done. Your starter for today then is another Beat It challenge. So I've written you 5 different questions for you to have a go at, so let's have a look. So number 1 is 0.7 times 100. So remember, if we're multiplying, the number's got to get bigger, hasn't it? And then you've got 12 divided by 100. So remember, that one's got to get smaller, so it's got to be a decimal, hasn't it? 483 to the nearest 100. So this one is a rounding question. So remember, look at your hundreds, then look at the digit next to it. So look at your tens. Is your tens above or below 5? Think about whether it's going to be rounded up or stay the same. 3/8 of 32, so a fraction of amount question. For this one then you need to do 32 divided by 8 and multiply it by 3, don't you? And then the last one is a bit of a bid maths question. Remember, we always do our brackets first. So do what's in the brackets first. So you've got 3 squared, add 3. And then once you've got your answer for that, you can multiply it by 5. Okay, so set yourself a target, set yourself a timer. Maybe challenge yourself. If you could do it in 3 minutes last week, then maybe set yourself a 2-minute timer and have a go. Don't forget to take a picture of it and send me a picture in the email. Okay, so that's your starter for today. Your learning question for today then is, can I answer area reasoning questions? Now we've done a little bit of area recently, but we're going to go over it today and go over the reasoning side of it, because I know you can all calculate the area of simple shapes like squares, rectangles, but I want to make sure we can do the reasoning side of it. So your pages for today are pages 50 and 51. Okay? So before we start though, before we even look in our books for today, I just want to quickly go over the area of triangles with you, because I know you're all secure with finding the area of rectangles, squares, and even parallelograms, but I just want to make sure we're all definitely secure with triangles. So remember, the formula for finding the area of a triangle is multiply the base by the height, okay, and then divide by 2. That's a really important part. We've got to remember to divide by 2, okay? So let's have a look together then. So this orange one then, the base is 6 and the height is 5. So we would do 6 times 5, which is 30, and then we divide it by 2. So the area of this triangle, changed colour, would be 15 centimetres squared. Okay, remember we always say it's squared if it's area. Okay, let's have a look at this blue one then. So the base is 10 and the height is 2. So you do 10 times 2, which is 20, and then you would divide it by 2. So the area of this one would be 10 centimetres squared. Okay, this one then, you'd do 8 times 3, which is 24, and then you do half of 24 is 12 centimetres squared. Now the last one then, I think we've got the gist of it now, you do 7 times 5, and then you would half it. So 7 times 5 is 35. Now your numbers aren't always going to be just an easy to half, okay? But I know that you all know what half of 34 is. So half of 30 is 15, half of 4 is 2, so half of 34 is 17. Half of 1 is 0.5. Okay, so your answer for that one then would be 17.5. So don't forget, don't let it throw you off if it's a decimal number. Okay? So now we've gone over the area of triangles. That should help you with question 1. Question 1 then, on page 50, you have got these triangles with these letters in. And it says, which of these triangles has a different area to all the others. So the first thing you're going to have to do is work out the area of all of your triangles. Okay, you haven't got any numbers written on there, so you've got to use the squares. So the clue in the question, oh sorry, it's not in the question actually, it's on the next one, but it's a centimetre square grid. So the base of this triangle is 1, 2, 3, 4 centimetres. Okay, the height then is going to be 1, 2, 3. So you need to count up. Okay, so then to work out the area of this triangle, you need to do 4 times 3, which is 12, and divide it by 2. So the answer for A is 6 centimetres squared. So you need to go through, work out the area for all 6, and then see which one has a different area. Okay. Question 2 then, it says, on the centimetre squared grid below, draw 3 different isosceles triangles that each have an area of 4 centimetres squared, and then you've been given a grid to draw it in. I'm going to need you to try and find a ruler today to help you with this. If you haven't got a ruler, try and find something that's got a nice straight edge. So you could use another one of your CPG books, just to make them as accurate as you can. So let's have a look. I've gone through and highlighted my key vocabulary. So this is on a centimetre squared grid. So we need to remember that. We need to draw 3 different triangles, and we need to draw 3 isosceles triangles. Now an isosceles triangle, you might already know what that means, but it means it's a triangle with 2 equal lengths. So 2 of the sides in your triangle need to be the exact same length, like this kind of triangle. Okay. Oh. So those 2 lengths there are the exact same. Okay. It's got to have 2 lengths that are the same. So for this one, you need to make sure that the area of each one is 4 centimetres squared. Okay. So you need to work backwards. So have a think, what do we do? So we multiply the base by the height and we divide by 2 to get the area of a triangle. So work backwards. So multiply this by 2. So if you do 4 times 2, that is 8, isn't it? So your base and your height have got to multiply together to equal 8. Okay, so if you just make sure when you draw your triangle, if you multiply your base and your height, that they multiply together to equal 8. And then you divide it by 2 and your area would be 4. Okay, so you have a go now then at drawing 3 isosceles triangles with an area of 4 centimetres squared. Okay, just remember that they've got to have 2 equal lengths. Okay, they haven't got to look exactly like this, but they've got to have 2 sides that are the exact same length. Okay, so that is most of your questions on page 50, and then down the bottom you have got a challenge question to have a go at. Okay, so it says here is an irregular shape which has been divided into 3 triangles. Use the triangles to find the area of the whole shape. Okay, so you can see here, I'll just draw on roughly. That's a triangle, that's a triangle, that's a triangle. Okay, now you know how to find the area of a triangle, so you'll be able to find the area of each one and then add them up to work out the area of the whole shape. Then it says, now draw your own irregular shape using straight lines. Split your shape into triangles and use them to find the total area of your shape. So then, once you've done that, you have a go at making your own. Okay, so you can just draw that on a piece of paper or in your purple book and take a picture of it and send it on your email. I'd love to see what shapes you all come up with. Okay, so that's page 50. Page 51 then is continuing with area, but we're moving on to the area of a parallelogram. Okay, we did go over the area of parallelograms last week, so I know that you already can calculate the area of a parallelogram, so we're just going over the reasoning side of area parallelograms today. So let's have a look at question 1. So it says, a garden is a parallelogram with a length of 12 metres and an area of 36 metres squared. A rectangular pond cover has the same area as the pond, but its length is 1/3 of the pond's length. How wide is the pond cover? Okay, so to help us out, I've got a parallelogram, I've got a rectangle, and I've put on what we already know. Okay, and this might help you if you draw something like this in your purple book. You could just draw it roughly because sometimes it helps to visualize it. So we know that we've got a parallelogram. It's got a length of 12 metres. We don't know the width yet, so I've left that one blank, but we know the area is 36 metres squared. So to work out the width, we can do 36, do the area divided by the length, can't we? So you can do 36 divided by 12, and that will give you your width. Okay. Now, it says a rectangular pond cover has the same area as the pond. So the area of the pond was 36 metres squared. So I know that my area of my rectangular cover is the same. So that's 36 metres squared as well. But its length, so the length here that I've left blank, is 1/3 of the pond's length. So the pond's length was 12 metres. So to work out the length of the cover, you're going to have to find out what 1/3 of 12 is. Okay, so I'm just going to write that there. 1/3 of 12. Now we do fractions of amounts in Beat It all the time. I know you're all really confident with finding fractions of amounts, so I know you will be able to work out what 1/3 of 12 is. Okay, then it asks us how wide is the pond cover. So once you've got that answer, you know the area is 36 metres squared, so you need to do 36 divided by your answer for this one, and that will give you your width. Okay? So you have a go at that one. Question 2 then. Mary wants a parallelogram shaped window for a doll's house. The base of the window should be twice as long as its height, and area of the window must be less than 90 centimetres squared. Okay, so again, I've drawn my parallelogram ready so that I can put my notes on it and see where I'm up to. Okay, so the question then says, if the base and height both have to be a whole number of centimetres, what is the area of the biggest window Mary can make? So this one is a little bit of trial and error, okay? So remember it says the base of the window should be twice as long as its height. So I'm just going to pick a random number. I'm going to try my base. I'm going to try 14 centimetres. Okay. So if I know that my base is twice my height, I've got to half this to find my height. So half of 14, let me get an arrow. So this is my height. So my height then is going to be 7 centimetres. Okay, then you're going to multiply those two together to find the area. But it said our area must be less than 80. So let's multiply those together, see what we get. If it's less than 80, then it could be our answer. So we'll do short multiplication. So we're doing 14 times 7. 4 times 7 is 28. So remember, put your ones and carry your tens. 1 times 7 is 7. Add the 2 is 9. Okay, so that would equal then that the area was 98 centimetres squared. That's too big, isn't it? Okay, so you then are going to have to go maybe one smaller. So you could maybe try, you can't do 13. I've done 40, but you can't do 13 because it says that they both have to be a whole number of centimetres, and half of 13 isn't a whole number, is it? So you could maybe try 12 and do 12 here, 6 here, do 12 times 6, see what you come up with. But remember, the area of the window must be less than 80. And here is a bit of a clue. It says, what is the area of the biggest window Mary can make? So just make sure it's the biggest. Okay? You have a go at finishing that one off then. Remember, it's trial and error, so you might not get it first time. That's fine. Just keep trying. Then you've got another challenge question on this page. Okay, so this one says, Carl has made a wooden frame by joining together 14 parallelograms. So you've got all your different parallelograms here. You've got one in the middle. Okay, so it says each parallelogram has a base of 4, but they all have different heights. The white parallelograms are 2 centimetres high, the grey ones are 4 centimetres high, and the black ones are 8 centimetres high. So you now know the measurements, the measurements for each of your parallelograms. So you can go through and work out. So once you've worked out one black one, you know what they all are. Once you've worked out one grey one, you know what they all are. And once you've worked out one white one, you know what they all are. So you've only got to do three calculations. Then it says, calculate the total area of wood in Carl's frame by calculating the area of each parallelogram. Can you think of a quicker way to calculate the area of wood that only requires one multiplication? So there's a little challenge for you. And then it says, can you make another wooden frame using a mixture of 10 white, grey and black parallelograms that has the same area of wood as the frame above? So that's another little challenge. So in your books, so you're going to have to use your ruler, aren't you, to measure. Have a go at drawing your own frame like this consisting of parallelograms. Okay, and make sure you pop the measurements on there so that you can work out the area of the whole frame. Okay, so quite a bit of work for you there today. You've got areas of a triangle on page 50, you've got areas of a parallelogram on page 51, and then you've got a couple of challenge questions, okay? So once you've done all that, don't forget to pop on to Times Table Rockstars as well and take part in the battle that we've got going on at the moment, okay? So don't forget to send me the pictures of your work. I love seeing your maths work. It's brilliant to see how well you're all getting on at home. You're all making me very, very proud. Okay, see you tomorrow.